Welcome to the 6th instance of machine design at the second West Michigan Lakeshore Solidworks Users Group here in Holland, Michigan for 2019. About me, what I hope you guys all learned something, jumping into Solidworks. Make sure the recorder's still working. All right. So I did save off the files from last session. I'll upload those independently. So video 5 will have 5 files and video 6 will have 6 files. All of this is being recorded and should be uploaded to YouTube sometime next week, maybe. So let's open up our assembly again. Now we want to dump an 80/20 guarding package on top of this. And we're going to change a few things, make it fun. Oh, I do. At least the recording picked it up. Now everybody else should be able to see my screen. Sorry to the audience members. So same type of 3D sketch, right? So I'm going to click on the top plane and do our normal 2 and start sketching lines. Again, we do each line at a time because the rectangle command inside of the 3D sketch, in my opinion, is a little wonky. Can't quite get those picks today. Line that up. Come on. Midpoint. And I don't know what this is, 50 inches something. This is like 17 or something. So that's the top, and now we can draw our legs down. If you're in the 3D sketch mode, the tab key will give you your 3 orthographic views. You can see this coming straight out at you. This one's going down to the right, and this one's going back to the right. So the tab key is what changes what X, Y, Y, Z, or ZX plane you're drawing on. So in this instance, I just want to draw straight down, double click in space, draw straight down. So this is a pick and drag and let go, and this is a click, move, click, and then double click in space. Either way it works. Box select and equal, and put some arbitrary height on here of 36 inches, that works fine. Gonna draw across like this, tab to re-index, that's fine. Let's call that 2.5 inches. And looks like a good guard to me. So green check out of that. On our weldments, do our structural members. So this is all pretty standard. I'm assuming everybody's done this. So I have an 80/20 folder, 15 series. One key thing that I did here that I would encourage everyone to do as well is I added a light feature, which we'll look at in more depth in a minute. And so again, first pick wins. Specifically with 80/20 is we don't ever want miters. So on group 1 here, I'm going to choose my end connection, or my end joint, corner treatment, whatever they call it, and pick end butt 1. And you can see how it's going to preference going around clockwise, right? This extends, that extends, this extends, that extends. What we don't like about that is it's non-symmetric, it looks weird. So I'm going to pick on this magenta here. And this is one instance where you should click on this, not for the trim order, but for the corner treatment. So I can switch the corner treatment to make the back and the front extend all of the way to the end, like that. This is also a great way to minimize the number of unique bodies. So if you've got, like, if you're trying to do a jog through something, you want these two to be the same, this to be unique, and these two to be the same. Well, if each one extends going clockwise or counterclockwise through, you get a bunch of unique bodies along the way. So applying your corner treatment as far as your end connection or corner treatment with those magenta dots is very, very valuable. And of course, this is trimming properly because I did the first pick wins, and green check to rebuild. Now on 80, if anybody knows the 80/20, they know that there's a lot of little divots in here. There's typically a divot here. Actually, I'll just draw another one here to show that. We'll pick the not light one. 15 profile. And I'll gladly share these files with anybody. I'm sorry? Yeah, so what I did is I just, anybody that knows how Solidworks weldment profiles are powered, this is another instance where, well, he's no longer here, where fillets or chamfers in your sketch are necessary, right? But you can go to your weldments profile folder and copy it out, rename it, do whatever you want, and then you can edit that sketch. So I took out all these divots. Also, some profiles, they have like holes in the middle of here for lightweighting. So if the mass in the model isn't important to you, I take out all the lightweighting holes because it's just more geometry to handle. So you can always play with that, right? It doesn't have to be geometrically accurate and weighed to the exact ounce for most of everything I ever do in life. I'm assuming you guys are similar. So certainly the mass is important, but this is close enough. If you really wanted to, you could like thin something out to equal it out and make simpler geometry. That's the same way. So very similar to a, yeah, save it. Reduce file size, improve graphics performance, improve load time, everything, right? All those triangles are just gonna slow everything down. So same thing as the weldment, right? Front, top, ISO, right? And if we right click, tables, weldment cut list, green check, it'll pull in properly. 80-20, 15-15 profile, 51 and a half, 15 and a half, so on and so forth. All right, now we still have a problem with how do we bolt this together. This is really straightforward because all the connections are in the corner. But if you've ever been given an 80-20 weldment print, right, if you're given this print, and it says cut it on the saw, drill the appropriate holes, and put it together, that's really frustrating. Anybody had to do that? All right, next opportunity you have. Do it yourself and see how you like it. So when I was a junior designer, I didn't know any different because I built 80-20 myself, but it was usually like measure the tape measure, cut it. Oh, I got to drill a hole here, drill the hole, do it, right? I had never worked from a print. And so I had done it myself. It's pretty easy, pretty intuitive, right? So I did my first 80-20 print, sent it to the shop floor, and they dicked around with it for a long time. My boss called me out, and my boss was, at the time, was pretty famous for you do it yourself. First time. If you can't figure it out as the designer, how in the world can they figure it out? Like, you know, fix it. It's your fault. All right. Which is fair, right? So this was early in my career, right? And at the time, I was the only SolidWorks designer at this particular company. So I didn't have anybody to go ask, like, how would you do this? It was just like, Andrew, you're using SolidWorks. Everyone else is using AutoCAD. You know, you got to figure it out. So again, we've got the same thing. We've got weldments and machined. Now, none of this is really welded or machined. So we can pretty much ignore the second configuration. I'll often delete it. Reduces file size and load time. So the next thing we really need to do, those of you that know 80-20, a 5/16 button head cap screw will fit inside of here, and you can, and then all of this is, I think it's, yeah, it's 262. So this, you can tap every end with a 5/16 tap, and it works perfectly, which is really convenient. So I'm not certainly going to do a whole wizard tap every end, because on the print we just say, you know, tap all ends, because it's just run it in, run it out, it's easy. But if this hole was tapped, a 5/16 button head cap screw, or button head screw, like an Allen screw would fit in here. All you need is a hole through this member. So you put the screw in, you slide the T-slot in, and you put the wrench through the hole and you tighten it down. Everyone's familiar with this, right? This is not new to anybody. So from a 3D design and print standpoint, how do we pull this off? Oh, I had also mentioned that another acceptable way is to have this vertical part run all the way through and turn both of these, right? Whatever your design style or preference is. How do we do that? I'm sorry? All right, so you're like, click on this, start a sketch, extrude that, cut through all. Whoops, wrong direction. So you're kind of in that camp? Okay, so how do we accomplish that in a different way? Any ideas? It's pretty unorthodox, but it works super well. So we do a hole wizard, ANSI inch, fractional, and 5/16. This model through all would probably work pretty well. Positions start 3D sketch, see where I'm going, and then we're going to click up on here and here. So it's pretty quick to do. So we just need holes there and there. Now 3D doesn't mirror very well, so we're just going to keep going around and doing this. Oh, their sound system is loud. I can hear it in here. Hopefully that's not in the video. So then we're going to put a hole. Oops. You got to be a little careful because they'll try to jump to an edge. You just got to watch it. So put a hole in here, put a hole in there. Now this might seem a little tedious, but trust me, there is no faster way that I've been able to find. If you know a way, let me know. And then, if you rotate just the right way or go to wireframe, you can grab these holes and do concentric. So, or you can do also like select other, right? So I could right click here, select other, grab this, grab that, concentric, and right click, select other, grab that, concentric. Or again, we could do wireframe, which as long as you can pick it out, it works right. So we grab this, grab that, concentric. Another reason why the light profile is absolutely valuable, because it's just that many less lines. And I won't bore you with the rest of it. It'll take a couple minutes. But when we green check, we'll have perfect design intent holes, all with one feature. So you can literally do a massive, I've done like maybe a 40 individual body, 80-20 frame with 3 features: sketch, structural member, 3D hole wizard. And then when you jump to your print, oh yeah, so we got a couple there. So because I'm adding 3D holes, you're going to get new unique bodies. Because SolidWorks always calculates the body off the unique geometric hash and compares them. So if I put a hole in one body and not the other, it'll say this one body is unique, not that one. That's another specific to Guardian, another reason why you really want to do symmetric design and symmetric holes and constrain the holes to the, the tapped hole in the other part, because that'll all be perfectly the same geometrically with one hole wizard. So I honestly should probably finish it because I've got the time, and otherwise nothing's going to look right. All right, so pretty happy with this new computer. It seems to be working well. I'm going to get a couple more settings fixed, but. And we just look for the blue, right? Blue is undefined. If you rotate the right way per corner, you can grab both of these pretty easily. Hold down Control, and with your center mouse button, instead of rotating, will pan, if anybody didn't know. And we got these. This will be a little bit harder because it's farther down that tube there, but still pretty straightforward. Any questions while I'm finishing this up? Nobody? All right, I think that looks good. So I should have the same number of bodies. We should see this little shrink. If we start out with 5, we should only have 5. Because every body should be symmetric in its application. Now, another design methodology with, let's just turn off hidden lines because that's obnoxious. You could also turn off under tangent edges. You could turn off tangent edges and really clean a lot of this up. So here's another frustration. Tangent edges removed. So it's not going to show the tangent line, right? So if I remove the tangent edges on this, it doesn't remove on any projected views. So everything else has like use parent style, use parent scale. You can link to parent on configurations. There's no way to do that on hide, show, or with fonts tangent edges. But you can just delete them all. And if you project your views after the parent already has them turned off, the rest of them will inherit. So when I'm doing a lot of weldments, 80-20, or anything where I care about whatever your defaults, because you can default it on or default it off, right? So whatever your default settings are. Anytime I'm doing a drawing where I want opposite the default setting, I'll sometimes add all the views to adjust white space and scaling and then delete them. Or sometimes if I know what I want have, then I'll just make the one, turn them off, change my display style, fix everything I want, and then do my projections out and save the time. So your mileage may vary, whatever you like there. So here, same ballooning applies, right? It's just like a weldment from the first session. We can balloon kind of anything we want. That's all great. We can do this. Should only have 5, so this should be all I've got. 1, 2, or 2 2s. 1, 2, 3, 4. We have 5. What am I missing? Oh yes, you're correct. And none of the, well, no, I have that right here. Oh wait, I got this one here. Or this one. Ah, there we go. Okay, so I got 1, 2, 3, 4, 5. Balloons look crappy, but so be it. So then on my relative view, I'm going to grab this front, right. Okay, now if you didn't know, you can add another sheets. And you can actually like Control X, cut this out. It shows you delete confirmation, which is not confusing. And then you can paste in that which you just cut or deleted. Rotate this out to 90. If we look at this, again, we're going to turn tangent edges off. That looks fine. So you got my hole here and my hole flipped. So I certainly need this view and that view. Let's change our scaling to something that works good for detailing, so 1 to 4 maybe. Right, it's rather large. The only thing I care about are the holes on the end. So before I do that view projection, let's do some split lines, or break lines, and break them up. And who knew that you could dimension your break lines? Did anybody know that? Great question. So, what are the 2 rules in design? So if I break my model and my model grows in 10 inches, what happens to my drawing? Or if it shrinks 10 inches, what happens to my drawing? Right? It's the same rule why we don't have undefined sketch and we don't have undefined models and assemblies. This is now a fully defined break line. No matter what, the only thing that could happen is if that piece of aluminum got less than 4 inches, because my break lines are 2 inches, right? If it got less than 4 inches, I'd have a problem. But as long as my model is somewhere 4 inches to infinity, my drawing should always update, the break line should always be correct, it's fully defined, and you're never going to have an issue on the drawing.
So you actually go in
It did, yep. So when you click on the break line, the 2 dimensions show up. If you click off of it, they go away. So I can actually, and it's just a regular dimension, right? It's just visibility is, yeah, okay, so 30 didn't work. I've actually had some issues with them rebuilding. It's a little weird. Not sure why.
But the premise is that there's no undefined.
So, I'm sorry?
But the premise is there's no undefined.
Yes. Yep. I mean, this is just the display style cut, right? So, or the display view cut. The other problem with 8020 is it sticks to everything. All right, so we got that. And then we could just do our standard, this item is so long, right? It gives us our little break line in the dimension. And ordinate dimensions don't really work because we're not using machines, we're not using a vise, we're not using that. So then I would just do 75 typical. And of course it's an 820, of course we know it's 1.5 inches, you know, both directions. And then here I would project out to here. It should inherit the break lines if the break lines are done before the projection is made. So that's another key difference there. And then, and you just do that like 3 or 4 times, however many times we need to do that. Generally, I could have done this model better, honestly. But generally when I'm doing 8020, I try to do it modeled in such a way that the least number of members need holes. So what I could have and should have done better, if I so chose, was these verticals, if I ran them all the way up, then only the verticals would need holes. All of the horizontal members would just bolt in. And that is a viable option, right? So now I gotta also pick a vertical. All these verticals happen to be the same. No, they're different. Yeah, so I really screwed that one. I could have had 2 unique bodies that had holes, and now I've got 3 unique bodies that have holes. But the nice thing with this is once I have a drawing here, and it depends on how clouded the print is, but a lot of times I'll just draw a dividing line. Call a balloon out on here. So now I can do the relative view. This is still considered a normal view, so I can still pick it, grab this, and say, this is front, this is right, go, drop it. We're gonna rotate this 90 degrees, great. Tangent edges off. I guess hidden lines are right. So I've got this one hole here. And certainly the hole is, if I can grab it right. This is not a 3/4, most of the holes in this instance are 3/4 off, right? So then from here, we can do the same thing, break it there and there. That should be, I like 2 inches because it works well on this model. And that's 2.5, so certainly this should probably be like, 5. Works great. And as soon as you get off your break lines, they all hide, so that's helpful. Make this sheet scale, so it should grow. Fantastic. We're going to project this up. Break lines inherit. And, oh no, that's the front, so that is the only hole. I was thinking it was the back. No problem. So that's 3, and then, another line, another one, so on and so forth. I don't really feel compelled to do the last one. So you can do entire guards, 3 features in your 3D model, generally 2 sheets on your prints. Here's your final sheet, and of course, I'm being lazy because, right, it's presentation mode and not actual go to print mode. But same rule with weldments. We design all out, or we dimension all outsides to outside so we can hook the model and measure. Best practice. So on here, so on there. Make sense? Any questions? All right. So I shamelessly copied some purchased parts from another project I had going on. Hide that. So front to front, right to right. And then here, we're just going to do coincident to there. Now this is an interesting thing. I would generally short my frame a couple inches or short the guardian a couple inches because there's no way to mount this from the bottom if it's right on the edge. Right, so if I measure this, I got 14.25, so math is 28.5, which is just easier to do it, plus 28.5. And then I gotta short this, it's a 1/2 inch, no problem. 16.5, you just do the math and type in the equation. Right, this is not a possible to mount. So a lot of times I'll shorten the frame a couple inches because the frame doesn't really matter, and then especially something this so wide, right? And which we could do. So let's grab this. Let's shorten it just to maybe 74. Sounds like a good number. And then now we can do 5/16 counterbore backside. In this instance, I may not even counterbore. I might just do a through hole because the head on the back doesn't really matter much, or maybe use a button head. Because I don't want the double setup on the boring mill, because I'm going to counterbore and do a bunch of stuff on this side. So I really just want to set it up once. If they are going to counterbore it, I would expect them to do it by hand. You can technically do a countersink, although that's really messy as well. So generally bolts on the bottom like that aren't a big deal, especially if you use the button head. So I would probably just do a through 5/16, have them build the guardian and drop it on, and bolt it up like that. This isn't a really practical thing to guard because I think it's all a hand fixture, but you get the idea. Any questions or comments on that?
After the 3D sketch for your holes,
Yes.
if you were to use the normal hole cloth and you call out a hole or do
Yes. Oh, good point.
what quantity would it say?
It would give you the full quantity. Yeah, good point. I didn't talk about holes. Thanks. So you're correct. If I take my hole wizard, or my hole color, if it works, does not work. I think my settings are broken. If that was working properly. I don't know why that's not working, honestly. Like I said, I just got this laptop, and so I would expect this to be forgetting where my variable button is. Maybe that's what's broken. So usually there's a button you can click that'll show you all the whole callout variables, but I don't have that button because I think something's broken. Let me try to figure out what's wrong. So I don't know why that's not working. I'll have to dig into that later. But yes, it would say, 17 times or whatever that value is. I am. Yep, sorry. So typically what I would do is make a big note up top here that says all holes are, I can never spell clearance. Clearance through 5/16 and make that something large. So typically on 80/20 with stuff like this, I generally just show the geometry and show hole placement and just say every hole is this because I'm not going to do that. And then that way they just kind of sit. I mean, a lot of times the holes are, 3/4 of an inch off the edge and they just have a blind block and a drill press and they ram it in there and drill it out. And then anything else that was mentioned and scribe and, cut out by hand or drill out by hand. But this is a really effective way in Solidworks to do 80/20 or similar products. A lot of the similar products have like weird anchor mechanisms where you go in an inch and you drill a big hole and you buy a special piece of hardware that then the through bolt comes and grabs. Other ones don't have any support for that. You always have to do like corner brackets and stuff. So right, that makes it all the easier from the designer standpoint if you don't ever have to do holes. I find 80/20 to be the cleanest and the least number of tools and the least amount of cost as far as hardware goes to make it work. But I don't really know the price per foot on any of that.
So for an example of having a bunch of corner what's the process for that? You do the 3D sketch, you know the history of kind of jumping in back into the
Yep.
You do the 3D sketch, you build all the structure components, now you need to have all these corner brackets.
Yep, so you'd have to make an assembly because they are unique parts. You're going to have a unique bill or an item in a bill of material. So all good designers float and mate origins of their first part. I might actually have one on my desktop. Let's find out. I do not. Yeah, so I don't know if I can find one on 80/20. Their website is hit or miss, I find. Sure, I don't know. Not what I was thinking, but it'll work. Can I download this somehow? CAD download, CAD download. Hey look, I've got a login. Lucky me. CAD download. Wow, lots of clicks for CAD download. Let's filter to Solidworks. Solidworks, oh, I already had it selected, that's helpful. Perfect. So my naming convention is the manufacturer dash the manufacturer part number. So I would do 80/20 dash that. However you choose to do that, not really critical to this particular presentation. So now that I've got this part, we drag it in here. Because it's a purchase part, I always open up its own window, see if I have to hide, suppress, fix, do whatever, right? So here we're dropping into this. And again, you just want to rotate and mates, and then mates, mates, and mates. So you got something like that. Oh no, it's not the same width. So using breadcrumbs, I'm just going to delete that out. I hate doing width or symmetry, but if you have to choose, symmetry is better. So I'd find the center plane there and do something like that, symmetry, and go. Now this you'd want to have symmetric and mirror the crap out of it, because that's a lot of work for parts.
Is there a quick way once you got one in to, other than the mirroring aspect, like the smarts and others have that? That's why I was curious if
there's nothing super standard without a crazy amount of very specific niche customization that you could do that with. Because the problem is the weldment is, every face here is generated anew for the weldment, that you don't have a standardized enough face to be like, I want to snap this to the 8020, because the face IDs on the 8020 are different, going to be every time. If these were individual parts, like heaven forbid you work somewhere where they didn't allow multi-bodied weldments and every one of these had to be their own part file, heaven forbid. If that was the case, you could do something quasi-cool, but it would still be pretty limited. I am going to... So here's a quick example of SmartMates and how it would work. So I've got this folder on my desktop in my design library. This is super sweet if you can standardize and pull it off well enough. Most people can't, and that's kind of the challenge with all these automation tools. Nope, wrong button. So I'm going to create a design library now from my desktop for this folder of 100. Start a new assembly. Nope, that's a part. Helps if I do an assembly. So this is legit out-of-the-box SOLIDWORKS functionality. This is no third party, no custom programming, no anything. This is straight native SOLIDWORKS functionality, all right? Nothing, can't emphasize that enough, special. Folder 100, okay. So I set this up for a customer, and I think I didn't grab my piping, so this is gonna be a little weird. But they did a lot of sanitary fittings. Sanitary piping. It's not fog, but imagine like a fog. So I had the opportunity to design stuff from scratch up front, the way that I wanted to do it, set everything up, and then hand it to them on a silver platter and say, this is how you get to do it. There's no legacy, there's no anything, it was beautiful. So here's a T. If we drop a T in, they ask me which size of T I want. So it's all configured, right? So I want a 4-inch, I don't remember this numbering schema. So 100-04 I think is just the iterator sequence. So this is going to be 03 is I think 3-inch and 3T. 03 is 3-inch through with a 2T, 1.5. So this is T with reducer. So I think this will be a 3-inch diameter with a 1.5. Look at that. So we've got that going for us, right? So then, and what I forgot to do is grab pipe because I think that was in a different folder. So my apologies on that. But we'll just add a ferrule to the end. So everybody's familiar with a sanitary fitting ferrule, right? So if I drag it close to this, it'll snap and change size. If I drag it close to this, it'll snap and change size. So now this is an 1.5 inch sanitary ferrule, and this is a 3-inch sanitary ferrule. Then maybe I want an elbow. I think this is an elbow. So hover, changes to size. Now the problem is, no one's going to prevent you from double stacking, right? Because SOLIDWORKS is still SOLIDWORKS. So you hover over here. All right, that looks great. Now, because it matched the size, right, it knows that I want a 3-inch. It's intelligent enough to ask me, do I want 3-inch and 45 or 3-inch and 90? There's probably 10 configurations here of different diameters, but because it matched diameter, it's narrowing down, if you can see this, it's narrowing down my configuration options to 45 or 90. So I say, yep, 90 is what I want, or 45 so we can watch it change, right, is what I want. So now it'll update to 45. And maybe I want another weird 45 on here just for funsies. So now here's my entire list. Why it's not doing it the same as before, I don't know. But good enough for me. So we've got that going, and then you can even do it so I can drag it from the right again, from the task pane, but I can even do a control drag inside of here, and that control drag will still update and behave the same way. So you can drag from inside of your model and mix all this up. Now the really fun thing, and I may not have grabbed it, I only copied out so much data. Triclap, sweet. So the really fun thing is you can even, you can set all this up intelligently enough to actually honor spacings and stuff. So anyone familiar with a tri-clamp and sanitary fittings, you know that we've got these two ferrules in each end, you put an 1/8 inch gasket in the middle with a sanitary tri-clamp that squeezes all together. So if I want to add another one to this side, it'll actually add the gap that I need. Which also means if I drag in my ferrule, or my tri-clamp, it should, why didn't that one work? I don't know. That one might be broken, but it should have gone to the right size. And this is an actual assembly with a tri-clamp and the seal built into it. So I drag in the assembly. It's already got the gap between the fails, adds the seal, adds the clamp. And like we were talking last session, I don't know if this is set up that way, but like we were talking last session, each configuration has the hide show options where you can turn an assembly into a part. You can also dissolve an assembly with promote. So it's easier explained on a drawing. So let's make a drawing of this bastardized assembly now. Super terrible. Don't ever do what I just did. Because there's welded parts and assembled parts all in the same assembly. Very bad practice. I'm ashamed this is even being recorded. And so we throw a bomb on here. And nothing's even fixed to origin. So terrible. That's what demos are for, right? That's why you never trust a demo, because you're like, that was amazing. And then you actually got to do a lot more work to make it actually work. So here, if we look at this flyout, and so let's do, so this is top level only, so it's only going to show the components at the top level, right? So this should exactly match my feature tree, correct? Everybody knows the difference between top level, indented, and parts only, right? So top level, this should match my feature tree in 3D CAD. So if I expand this, I've got part, which is the seal, that's the clamp, that's the elbow, the ferro, the other ferro size, and the T reducer. So why don't I see the assembly? It's top level only. I should have an assembly here, and the assembly should have two children. Clearly, it's in my tree structure. Assembly is right there. However, the assembly itself has a bill of material option called promote. So it takes the children and it moves it one level up, keeping the assembly structure in 3D CAD. So I can drag in that assembly with two parts. It automatically mates in place. I only have two mates or maybe three mates to constrain that assembly. But from the bill of material standpoint, it says part with parts, because it takes those parts and it promotes them a level up. Solidworks will do this recursively. So if, heaven forbid, terrible practice, you promoted every single assembly, there would be zero difference between top level, indented, and parts only. Because you would have a 5,000 part top level assembly and there would be no sub-assemblies whatsoever. So promote is amazingly powerful in this instance, extraordinarily dangerous in other instances. But here's a way to build, and obviously like from a weldment standpoint, I should have stopped here, the tri-clamp and seal, and then that weldment and another weldment should be put in another assembly with the two weldments and the clamp and all that kind of stuff. But again, that's why demos are fun, because it's like amazing. So of course, if I just want to delete this, I could drag this over with control, snap it in place. Doesn't always work, evidently. So let's do a 90-degree 1.5 inches. It's just a configuration. You change it however you want. Drag that in place. Okay, I don't know why my snapping's no longer working. That's always fun. Solidworks at the best. So let's drag it in from here. Maybe that will work. Haha. So clearly there's some inconsistent behaviors, but if you get the opportunity to set it up right in your controlled enough environment, you can pull off really cool, and this is all native SolidWorks, nothing that any of your SolidWorks also can't do. SolidWorks has done this, I think, since 2008, 9, 10, something like that. Any questions on that? Kind of getting sidetracked from our machine design, but great question. That's how you could pull it off. All right, we'll go back to the machine. Close some of this stuff. Yeah. I guess I'm saving. Let's just see what we got to close. Close. Yeah. Sure. All right. So I got some purchased parts on my desktop that I'll drag in here in a minute. Copied them from a different project. Let's do these. I don't remember what they all are, so we'll just click randomly. Ah, light curtains. Okay, so I remember this. So if you have 80-20 frame going to the floor, you can buy these 5/16 with a lock washer, flex head, or ball and socket things. So you would just tap the bottom of this and shove it in there. One thing that I forgot on the print, shame on me, was tap all ends 5/16 15 all. Yeah. Sorry? Thank you. Not only can I not spell, I can't type. So, sorry? Yeah, right. I'm an engineer. I'm not expected to know how to spell. So obviously, if this went to the floor, you just tap the bottom, shove the feet in there, easy peasy. So that's that. We'll delete that. So this is a light curtain mount, light curtain status switch or opti switch. One of those two are, and then the corner, which we don't need anymore. So I want to show this. I don't remember what switch this was, but it looks like the clearance is 4/3 radius, so that's 8, that's 7/8. So I'm going to edit this part in place, drop in a fractional at 7/8 if I did my mental math, and decimal to fraction conversion correctly, which is always a crapshoot. So let's say we got a few of these switches in place, right? So stop editing that child, find this part, find the bottom, made it in place, make this. There's a new lock rotation on the concentric mate. So where you have historically had, I mean, some rare cases not, but typically you always have to do at least 3 mates to keep something from rotating. If you have a concentric mate, you're able to lock that concentric mate so that it will no longer rotate. So you have a single mate for concentricity, a single mate for coincident on where it is along the axis. You can lock the concentricity. So this is fantastic for hardware or anything like that. If there's something that needs to be oriented in a particular position, or with kinematic motion needs to be able to move around, that's not desired. You would have to mate it accordingly elsewhere. So I've got this part mated into one of these holes, and now I need it in the rest of the holes. If you didn't know, there's a super cool hole pattern feature called pattern-driven component pattern, which is a great tongue twister. And all you have to do is pick the component you want to pattern and pick the patterning hole wizard or other child patterning feature, and it'll put that everywhere there's a hole wizard. Which means if I go to edit this plate, this is again one of those super wonder demo functionalities. And I say more holes, and you rebuild, and there's more switches. It's so cool. So I don't like doing it, but this is one compelling argument for if you had like, let's say there are 2 different things that needed 7/8 that went in 7/8 diameter holes, and there was a higher quantity, like a dozen or something. I would probably do 2 different hole patterns, one for opti switches and one for stack lights or something like that, because you could pattern them out and be intentional about it. Sometimes I'll just tweak the sizes a little bit, because like if this was an extra 16th inch, nobody would care, and you just get a different drill bit or interpolate the hole differently. So then that way the machinist is not looking at like, this idiot, he's got 2 identical holes with 2 different patterns, because that does look kind of bad. But this is an instance where I would intentionally do 2 different patterns to drive those features, because it helps out a lot, saves you on the mating. You can also do instances to skip right, so maybe I don't want those, maybe those are stack lights or something like that. But then you can mate something in the other hole and pattern it and skip the other instances, but then if you add a hole, they both add, and you got to exclude one from the pattern. It's just not good parametric self-updating design, but it is an option. So light curtains was the other thing I was going to do. Light curtains are a little frustrating sometimes. I don't really know when my hour is up. But, some adult will tell me when my hour is up. So light curtains are interesting because they're 2 independent different parts, but they're 1 part number. So on the bill of material, I'll only ever want to show 1 part, but I need to put 2 independent parts in my assembly. It wouldn't work really well to put them both in a subassembly, because then the subassembly has to be flexible and I have to constrain the subassembly, and Solidworks doesn't like inter-assembly flexibility relationships with independent distance or positioning mates per part. So we would, and I'm not probably gonna have time to mate all this in place, but let's say that this is gonna mate here. Drag that up. All right, so that's a thing. And this is a thing. Nope, wrong face. All right. So we got those two things going. So in this instance, when I would download or name the parts, there's many ways. In this particular instance, these are from Japan, obviously, with the Japanese characters there. So this is a Keyence sensor, Keyence light curtain. So I would have Keyence, the normal part number, and I do like Keyence-L for the left hand, because the one is the transmitter receiver and the other one is just the mirror, right? Or it depends on the light curtain technology, you can do both directions. Sometimes I'll, instead of L, which by the way, who knew you could rename parts inside the feature tree? Awesome. So I'll quickly show this here. Move this over to the side. Da, 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 da. Sounds like the guys next to us are finishing up. So if we look at this one here, so it's Keyence GL32H_L. So I changed this from _L to space exclude. That's a lot easier to find in the bill of material. And I hit save, it'll say, hey, do you want to rename? I say yes. And then if I save that, it'll say, hey, do you want to save this on the disk? I say yes. And now it says -exclude. So if you have a file on your hard drive that's in an assembly and it's only in one assembly, you can rename it and it'll change the name on the disk and change the name in the assembly. You don't have to do a save as and a replace or anything like that. The problem is if that one part is used in 10 assemblies, you have to open 10 assemblies, or you have to have integrated PDM client, or another slow way, which I have had Solidworks crash on. So let's see if it happens. When you hit save, you can also click update used instances, and it kind of scans your hard drive of where it thinks files might be. There's a bunch of rules that control what this is. And there are settings in SolidWorks that can control it. But I found, at least my last laptop, this laptop hopefully is better. But when it starts scanning, it just crashes out. So that's kind of a bad thing. As long as it doesn't lock up, you can stop the scan, which is helpful. You can include subfolders and locations. You can add folders to say, I intentionally want to search this part of the network. I intentionally want to search this project file or something like that. But you can just say, OK, and it will update that to now exclude -update. And now it's saving again. Maybe it'll crash on us. How exciting would that be? Oh, buddy. I mean, yay, SolidWorks is great. So renaming the feature tree is really helpful, especially for machine design. So notice in here I was doing a really bad job at naming files, riser, plates, update, guard frame. If it was a real project and I actually had a project number, I would be prefacing it with a project number and that kind of stuff. Again, from a demo standpoint, you just type whatever you want. But a lot of times I'll Andrew's try out, not sure if it works widget thing, and then, oh, that was crap, and throw it out and do something else. But now if you do want to recycle those files and give them proper names, you just got to know the next name, rename it in the feature tree, and save and move on. It's really, really helpful. Obviously, if you have drawings made at that point, the drawings will break, or update, and then you have to do a rename of the drawings, which admittedly I haven't tried, but I don't think is supported, if I had to guess. Guarding. I don't think there's a rename option for drawings. So you'd have to go to the File Explorer. I guess that makes sense because nothing references, it doesn't make sense. They couldn't do it. Nothing references drawings. So you can rename drawings all you want. Nothing should break because the drawing looks at stuff, nothing looks at the drawing. So you just have to find the right drawing, rename it the right way to match the right model. Yeah. Generally, by the time you get to drawings, your names better be right, is the moral of the story. Any questions or comments so far? It looks like other meetings are getting done, so I should wrap up.
Is there a reason why you would just exclude the one part from your model?
Yes, I would. I would name it obnoxiously like that so that I know to exclude it. Sorry, okay. I never actually finished that thought. So if you make a drawing, and you should always make a drawing, scan through your BOM, make sure you have materials and descriptions and that kind of stuff. If you see a -exclude, right, it's twice the length of anything else, then you know how to go exclude it. And again, I'll unexclude this a minute. Again, I would mention that the super awesome, don't have a drawing for this top level yet. We'll make a drawing, dump a BOM on it. The really great feature in the bill of material that, again, I find not many people know about is if you right-click, drawings, bill of materials, add a BOM. Hey, look, I've got a dash exclude. That's not right. I can expand my bill of material, right-click on this, and from the BOM, I can exclude from bill of material. Hey, this component will be excluded from the bill of material. To include the bill of material, right-click on it in the feature manager and select, yep, don't show me this again, okay. It'll disappear out of my BOM. So you can do bill of material display label, configuration, name, hide show children, and exclude, all manipulated from the bill of material. Obviously, once you exclude it, it disappears from the bill of material. So you got to go to the feature tree to go dig it out and re-include it. But if it's in the feature tree, if it's in the bill of material, you can kind of do anything you want. If you're in a PDM environment, you'd have to still have ownership of that file. So I might own the drawing, check out the drawing, not have the model checked out. I'm not going to be able to make those edits to a read-only model. So you still have document ownership to contend with. But there's a lot of features and abilities here inside the bill of material that sadly go underutilized. Any questions or comments on anything? Did everybody learn at least something? Yes. Mission accomplished. Again, I should finish on my PowerPoint because that's what I'm told to do. That's me. Thanks for your time. I appreciate it.